Welcome back, everyone, to the monthly sessions of Process Safety with Louise. As I mentioned on LinkedIn, we have changed the format a little bit, but to keep consistent, we're going to go through the same privacy message. I'm going to share my screen. And then we can just talk through that while we wait for everyone to join. Okay. So please remember that this session is being streamed live to YouTube and it will be available for playback on the YouTube channel. So just be mindful and respectful of what you say. Everybody is here of their own free will, as well as me, and also nobody is getting paid for this. We all may have a difference of opinion, especially when it comes to process safety, but the objective here is to learn from each other. So what is this session? So if you haven't watched the session before or you haven't attended before, it's a place to get access to industry experts and ask questions on specific topics once a month. It's varied on the date on which it is, but generally we try to do a Wednesday in the month and normally around noon in the UK. It's available for catch up on YouTube, and it's a place to share best practices for all of us to learn. Every time I do one of these sessions, I learn from it. So I hope that you do too. Today, we're changing the format a little bit. So I'm going to show you here. So we're going to do a quick introduction. So I'll introduce myself again as per usual, but we're going to do a bit of a longer safety moment. So what I heard from a lot of people on LinkedIn and also feedback from the session was that people wanted to learn from historic incidents. So today I've had a look at the Evergreen packing mill incident in 2020. Coincidentally, that's the same incident that's being shared by the CCPS this month. So you can have a one-pager where you can go and talk to your workforce about it. We'll spend about half an hour talking about that incident, and then there'll be time for questions. Okay, the questions could either be on the incident itself, and if I know the answer, I'll answer them. It could be sharing best practices, which could have helped prevent this type of incident if it was to happen at your site, or the questions could be on anything else process safety related. Once the questions are finished up, we'll wrap up and we'll meet again next month. Okay, so I'm just going to check the chat if you can confirm that you can hear me and you can see me okay in the chat, and I'll activate Q&A so that I should be able to see that as we go through. Okay, great, thanks, Louise. Okay, so I'm going to go back to sharing the screen, and I'm going to talk through the incident. Now, the incident I wasn't aware of before I was preparing for another course. I was doing a HAZOP course, and I wanted to include some hazard identification in the HAZOP course to demonstrate the difference between hazard identification and HAZOP. And I came across this incident, which has got a very detailed report by the CSB, but it also has a PowerPoint presentation with the summary of it, which you can use then to communicate with your teams. So I've used both of those pieces of information. A quick introduction to myself. So if you haven't been to these sessions before, my name's Louise Whiting. I've got over 11 years operational experience in process and process safety. And since 2019, I've been running my own business, Barberton Limited. I run these sessions free once a month so that people in areas of the world who don't have access to mentors or to anybody that they could ask advice from can dial in and ask free advice. Also, we're now moving on to sharing lessons learned. So hopefully this will also become a platform for us to learn specific lessons for the month so we can all start to improve. So this incident, it was quite an interesting incident, actually. So the incident happened during a maintenance activity. So the packing facility, it had something called a bleaching area. And what they did was they contacted the pulp with a bleaching agent, which made the pulp more white so that they could make white paper. You can see here that this is the location of the incident, and you can see the size of the industrial area where they were working. Relatively close to the water, but the location of the actual incident is not. So what was the problem? Why were they doing maintenance work on this vessel? So the vessel had two parts to it. It had an upflow tower and a downflow tower. In this tower, as I said, the pulp from the processing part of the plant was contacted with a bleaching agent to make the pulp whiter so that it could be used for more refined products. The upflow tower and the downflow tower were in contact with this bleaching agent, which was quite corrosive. Both towers were designed with corrosion-resistant alloy in mind, or corrosion-resistant properties. The upflow tower was made of a fiberglass resin liner, and that was resistant to the acid. And then in this tower, there was a brick liner, which then protected the stainless steel outer. However, over time, these liners were subject to damage, and two areas here, this area in the upflow tower and this area in the downflow tower, were identified to be damaged. So because the liner in the two different parts of the tower were quite different, they hired two different contractors. The first contractor was the one doing the upflow tower. So to be able to repair the fiberglass lining, you need to remove the degraded material using a grinder. And then once you've made a nice smooth surface, you can then reapply a fiberglass sheet and then paint it over with resin. The resin will harden, and then you repeat the process until you get the desired thickness. In the downflow tower, you need to remove the brick liner, clean up the steel surface, repaint it if required, replace the brick liner and repair, and then you are good to go there. So what were they planning on doing? They decided that they would do both jobs simultaneously during a full mill shutdown. Now, as we know, when we're planning maintenance, sequential maintenance can increase the length of maintenance and outages, which then reduces the revenue of your facility. So in this case, they decided to do these two activities together. So two parties would be working inside this single connected space during one time. They decided to do day and night shifts, again, with regards to timing. So if we do day and night shifts, it means that this activity is going to be finished quicker. So the team here doing the resin had a confined space entry permit, and the team here doing the work on the brick part of the downflow tower also had a confined space entry permit. Both permits did not permit the use of hot work or spark potential equipment. The resin which was used in this part of the tower was flammable. And so that was the reason why both permits did not permit hot work or spark potential work while the resin was being applied. On the evening of the incident, the team applying the resin were having some difficulty applying the resin. So they'd apply the resin, but once you apply the resin, you have to give it time to go off. If the temperature is low, it takes much longer for the resin to set. And so as the resin is setting, it's actually running down the pipe here, and it's pooling at the bottom of this part here, which obviously is not what you want. You want a nice even coat. Because it was night shift and it was a very clear night and the temperature was low, the team were having a lot of problems setting the resin. They had worked on other jobs, and they knew that the problems with setting the resin were related to the temperature of the resin. So they tried several different things to try and get the resin to set, and none of them worked. One of the workers in the party was able to get a heat gun, and he came into the tower here at the bottom, onto the scaffolding, which was supported at the bottom here. and they started to use the heat gun to heat up the resin and thereby set it quicker. The team in here were continuing with their work. They entered in through this manhole on the crossover tower, and their scaffolding was suspended from the top of the tower. So in this case, the scaffolding was supported from the bottom of the tower, and this is their manhole for this work party. And this work party had a separate entrance, and their scaffolding was hanging from the top of the tower. So this team were heating the resin with a heat gun after they'd applied it to the wall, and this team were carrying on working away, unaware to the changes in the way in which this team were now working, i.e. that they had now introduced a spark or a hot surface, which wasn't there previously, and it wasn't part of their permit. So what does this physically look like? So you can see here the upflow tower is a thinner tower. You have the crossover line, which is quite a large diameter, and then you have the downflow tower, and the downflow tower is where the second work party were, and at the bottom of the upflow tower is where the first party was. So all of these images have been taken from the CSB report, if you're looking for those later. So what actually happened? So as this team was using the heat gun to dry, everything was going well. The resin was starting to set. They were able to get on. At 5:15 in the morning, unfortunately, one of the workers dropped the heat gun into the tank of resin or the drum of resin that they had within the tower. There were 4 people in this work party inside the tower and 2 people in this work party inside the tower, and then they had people on standby outside. 3 of the 4 in this work party evacuated immediately. 1 person remained behind trying to smother the fire. He was unable to do so and he escaped. Once they had escaped, they notified the other party that there was a fire starting, and the team who were outside tried to radio the team who were inside, and they were unable to get a response from them. 5:25, so just 10 minutes later, the emergency response on site arrived, but given the situation on the ground, they decided it was not safe to try and rescue the people inside the tower. Unfortunately, the 2 people inside this tower were fatally wounded from smoke inhalation, because this is a nice chimney effect. The manway was open, and this manway was open. It drew in the air here, and the smoke was coming out, also filling this down tower. So they were unable to escape. So I'm going to pop up a picture of the heat gun. So this is the type of heat gun which I'm sure you guys will have seen before. And this was the heat gun that was used. So what went wrong? Well, the team doing this work here made 2 mistakes, as we can see with hindsight. It's very easy to see with hindsight, but they didn't identify them in preparation for the job. Number 1 is they didn't think about the ambient conditions, considering that they were doing day and night shift during this job. They didn't think about the ambient conditions with regards to temperature and setting of the resin and difficulty that could cause during the operation. Once they identified that problem, which was now a change to how they understood the job, they didn't stop and do another risk assessment or try to come up with a structured way of dealing with it. So that there was a change, creeping change, and they didn't stop the job. Then in solving the problem, they failed to clearly recognize the hazard associated with using a very hot surface in a flammable atmosphere. And as a result, they brought the hot surface into this enclosed area and unfortunately ignited it, blocking in this work party. Overall, when planning these 2 jobs together, consideration wasn't really given for escape routes. and communication between the two parties, and also what equipment might be needed in the event that something went wrong. So even though they were not supposed to use hot surfaces or spark potential equipment, there still would have been a potential that the atmosphere within this part of the column could have been ignited from some other means. And so therefore, there should have been a very clear escape route and rescue plan in place with appropriate equipment. When they set fire to the drum, there was no fire extinguisher inside the upflow tower. And so they couldn't address the fire very quickly. He was trying to smother it with something else. He couldn't address the fire quickly because they didn't have the fire extinguisher. This is very similar to another incident which the CSB investigated in Excel Energy in the penstock. I'll share the link for that in the YouTube chat. So they didn't although they knew it was flammable, they didn't identify the potential for fire. They didn't have a fire extinguisher. They also didn't think about escape route. So if there was a fire in this part of the tower, the natural place for the smoke to go would be through this manhole, which then immediately is blocking the escape route for this party. So was this the right escape route for this party, given that there was a potential for fire here? Should these two activities have been going on at the same time during the phase when the flammable fluid was present in this part of the tower? Perhaps some preparation and some finishing work could have gone on, but should this activity have gone on simultaneously with this activity when the flammable atmosphere could have been present? So if we're looking at each job in isolation, this one seems pretty safe. They're not using any flammable fluids. They're just destructing a small part of brickwork, and then they're cleaning up the steel and repainting, putting the brickwork on. Again, this one in isolation seems relatively okay. They're applying resin, which is flammable. If it sets on fire, they climb down the scaffolding out the manway to safety. But when we looked at the two jobs together, the question was whether they should really have been going ahead at all together. So this is a picture of some of the fire damage, and you can see why the rescue team had decided not to go in to the downflow column to rescue the team. There was extensive fire damage on this crossover line. And you can see also that the team really didn't have any chance at escaping through their only access way. So the question is then, was this the only way in which the team recoating the upflow column could have done it safely? Was it the only way? No. They had on previous jobs, not necessarily the same team, but the same company had identified the potential that the resin could be too cold and therefore could have a very long set time and lead to poor application, etc. And they had used these heat bands to heat up the resin and maintain it at a certain temperature so that the resin, although the ambient temperature was cold, the resin was hot and it would set in a reasonable time. You could then apply more heat bands if you needed more, or you could take some off if the resin was setting too quickly. So this would have been a safe way of heating the resin because this did not have the potential to get to the temperature to ignite the flammable atmosphere in that column or within the drum itself. So this solution was known to the company. It may have been known to the work party or not. We don't know that, but it was a solution which could have been deployed if the potential for low ambient temperature had been discussed in preparation for the job, and also the potential to block the escape route for the other work party was identified. Then maybe more effort would have gone in to ensuring that flammable atmosphere was not present. Now we can say, well, these guys, they violated their permit, and so there's nothing really we could have done anyway. The problem is that almost all incidents are linked to someone trying to do the right thing. So in this case, they knew that the facility wanted to start up, which is why they were doing the two jobs simultaneously. They knew that the timeline associated with them doing this job greatly impacted the timeline for startup. And so what they were trying to do is to complete the job in the scheduled time. That's what they were trying to do. They were trying to help. They were not willfully neglecting the controls of their permits so that they could act in a dangerous way. They were trying to help. And in most cases, when we look back at incidents, we can see that some control or other didn't work because somebody was trying to help or do what they thought was best in that situation. And if you want another example, if you looked at Block 10, which is another CSB video, you can see that the operations supervisor there was trying to start up the standby reboiler because he knew that the fouling on the duty reboiler was impacting operations. He was, again, trying to help. Okay, so what should we do after this incident? Again, these are just the same lessons I've been sharing for the last 6 months. We need to learn from the past. There are loads of lessons learned out there. The CSB is a great source. The CCPS beacon, which is issued monthly. There's also some from the European Process Safety Council and many others, and I'll share those on my LinkedIn profile throughout the month. But learning from the past is really important. We also need to identify the hazard. If we don't identify the potential for something to go wrong, we can't do all the other things afterwards. We cannot identify the preventative and mitigative barriers. We can't try and eliminate the hazard because we don't even know it's there. We really need to understand our hazards. So regardless of whether we've identified them or not, we need to understand them. By understanding them, it'll give us a better possibility of identifying them. And if we have identified them, if all of the parties in our workforce understand our hazards, they will better be able to manage them, which is the next step. And we need to be vigilant and diligent. Okay, I'm going to stop sharing now, and I'm going to open the floor up for questions. So you can either type in the chat or you can type in the Q&A, and I'll answer any questions that you have. If we don't have too many questions, I'll wrap up the session and then we'll meet again next month. So does anybody have any questions? Okay. All right. Well, what I'm going to do is there may be some questions on YouTube. If you have put in the chat on YouTube, I will answer those later. What I'm going to do is I'm going to wrap up the session now. If anybody has any questions, I can either answer them on LinkedIn in a post or through a private messenger, or I'll answer them on YouTube if you put a comment on. So I'll share the screen just to wrap up the last of the session, unless anybody has a question before we go. So what's coming up? The next Process Safety with Louise will be on the 6th of April at noon UK time. There are some useful resources on my website which are free. And also I'll be launching very shortly a process safety management checklist, which can really help you dig deep into how your systems are working without going into too much detail of the deliverables. But it really helps to understand where your gaps are in association with managing process safety across your site. It's currently built just to the Energy Institute guidelines, but I will be adapting it to this, the CCPS ones as well, to give us an option to use it both in Europe and in the US. If you want any more information on this incident, you can look at the CSB work there. So there's as I said, there's the PowerPoint presentation, which is really useful if you want to be going through with your team on site. Or there is also a more detailed report, which has all the details of the temperatures, etc., and also has some snips of the work permits. And maybe you can talk to people on site to discuss how they might have manage the work permit a little bit different. An additional extra information is that the CCPS have issued this month the process safety bulletin, which covers this incident as well. Okay, so thank you very much for joining us. I'm just going to double check that there's no questions in the chat. No, so thank you very much for joining us, and I'll see you guys next month, and I'll try and communicate a bit better the time, because now that I've moved, it's easier to set the times.